Hello everyone, welcome to Sarada Devi Maths classes. Today we will start chapter heights and distances. This chapter is very much related to trigonometrical identities. Actually, this chapter is an application of trigonometry. For example, let this A tower on the ground and a man standing on the ground, say he be at the point C on the ground and is viewing an object at the point A. Then the line joining the eye to the object at the point A is called the line of sight. Then the angle which the line of sight makes with the horizontal, this horizontal is called the angle of elevation. It's the angle of elevation. So here the angle of elevation is angle ACB. Like that, this is the tower on the ground. Tower is AB. Suppose the man is standing here and he is looking at the point C here. Then joining AC, this is the line of sight. Here the horizontal, if we draw the horizontal, this AT, then we can see that this angle which the line of sight AC makes with the horizontal is this. So this angle, this is called angle of depression. So it will come like this from here to here. Angle of elevation will be like this. So this is angle of depression. So angle DAC is the angle of depression. Here angle ACB is the angle of elevation. Actually this angle of elevation and the angle of depression both are equal. Now if you consider two towers like this on the ground, say AB is first tower and CD is second tower, then a man at the point A is viewing the top of the tower C. Then this is the line of sight. Then we can draw this horizontal. Then this angle will be the angle of elevation in that case. This point is E, this horizontal is EA, then here the angle of elevation is angle EAC. So here in this first case, if we take sine ratio, sine, what is sine? Opposite side by hypotenuse. Opposite side by hypotenuse. Opposite side is AB. So AB by hypotenuse is AC. Again, if you take cos ratio, that is adjacent side by hypotenuse. Adjacent side by hypotenuse. That is CB by AC. If you take this tan ratio, that will be opposite side by adjacent side. That is AB by CB. These ratios, sine, cos and tan, will often come in the heights and distances chapter. So here if you know this angle and one side CB, then how can we get the opposite side? Which ratio we can take? Is tan ratio. That is opposite side by adjacent side. Standard values we have studied earlier. Tan theta we can find. Then once the sides will be given, then we can find the other side. Similarly, if you are given this AC and one of the angles, we can find CB. How? That is adjacent side by hypotenuse. Which ratio? That is cos. If you are given the angle and this hypotenuse, we can find the adjacent side by making use of the second ratio. Like that, we can get the opposite side AB if you are given the angle and hypotenuse by making use of sine ratio. So depending on what we are given and what we want to find out, we can use these ratios. So here you should know sine 0 degree, 30 degree, 45 degree and 60 degree. Sine 0, that is 0. Sine 30, that is 1 by 2. Sine 45, 1 by root 2. Sine 60, root 3 by 2. And sine 90 degree, that is 1. How can we get easily? If you write 0, 1, 2, 3 and 4 here above this, and divide each term by 4 and then take square root of each term. Then what will get? 0 by 4, that is 0. Root of 1 by 4, that is root of 4 is 2, so 1 by 2. Root of 2 by 4, that is 1 by root 2. Then root 3 by root 4, that is 2. Then root of 4 by 4 is 1. Then cos ratio, just take this 1 here and then 0 here. Root 3 by 2 here, 1 by 2 here, then 1 by root 2 is here. Then what is tan? Sine by cos, that is 0 by 1, 0. Then here 1 by root 3, here this is 1, here this is root 3, this is 1 by 0, that is not defined. You should remember standard values of at least sine, cos and tan for doing this chapter, heights and distances. That is only needed actually. Next we will find the values of sine, cos and tan is trigonometrical ratios other than the standard values by making use of the tables at the back of the text. So we will do exercise 22a. So here the first question is, the height of a tree is root 3 times the length of its shadow. Find the angle of elevation of the sun. Shadow tree is coming on the ground. So this is the shadow. Rays of sun falling at the point A and shadow form like this. Then this is the point C. This is the angle of elevation. Here length of shadow, let this be x. Then what will be the height of the tree? Root 3 x, that is given. Then what is tan theta? If this is theta, that is opposite side by adjacent side, CB. We have to find out the angle of elevation of the sun. Tan theta is root 3x by x. X and x we can cancel, so root 3. Now what is the standard value? We can see that tan theta is root 3 when the angle is 60 degrees. So we can write that tan 60 degrees root 3. So what is the value of the angle? That is theta, that is equal to 60 degree. That is the angle of elevation of the sun. Now the second question is, the angle of elevation of the top of a tower from a point on the ground and at a distance of 160 meter from its foot is found to be 60 degree. Find the height of the tower. So here this AB is the tower. What is given? The angle of elevation of the top of the tower from a point on the ground and at a distance of 160 meters. So distance of 160 meter on the ground means this much length, 160 meter. So from this point, what is the angle of elevation? It is given as 60 degree. This line of sight and horizontal angle formed between those two, that is 60 degree. We have to find out AB, length of the tower. We can write in triangle ABC, tan 60 degree, that is equal to opposite side AB by CB. AB we don't know, other two we know. Tan 60, that is root 3, that is equal to AB by CB, that is given as 160 meter. So what is AB? On cross multiplying will get 160 root 3, that is equal to 160 into value of root 3, that is 1.732. So what will get? This is 0, 2, 1, 7, 7, 2. So 277.12 is the same as 277.12 meter. Correct it to 2 decimal places. So height of the tower, that is equal to 277.12 meter. Now the third question, a ladder is placed along a wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall and the ladder is making an angle of 68 degree with the ground. Find the height up to which the ladder reaches. So this AB, this is the wall and this the ground, and what is given, ladder is placed along a wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall. So this much length is 2.4 and ladder is resting on the wall from that point. So the angle the ladder makes with the ground, that is given as 68 degree. So this point, let it be C. Then what we have to find out? We have to find out the height up to which the ladder rests. So what is that height? AB that we want to find out. So what is tan 68 degree? That is opposite side AB by CB. Tan 68 we can find out from text. Tan 68, that is 2.4751. So 2.4751 is equal to AB by CB. We are given that is 2.4. So what is AB? We will get 2.4 into 2.4751. That is equal to 5.94 meter. That is the height up to which the ladder rests. That is AB. Now the fourth question is, two persons are standing on the opposite sides of a tower. They observe the angles of elevation of the top of the tower to be 30 degree and 38 degree respectively. Find the distance between them if the height of the tower is 50 meter. So here let this be the tower, say TO, and two persons are standing on opposite sides of the tower, say at the points A and B respectively. Then what is given? They observe the angles of elevation of the top of the tower to be 30 degree and 38 degree. T to B, that is the line of sight. Here this is the line of sight. Now here the angle of elevation in the first case is given as 30 degree and in the second case it is given as 38 degree. Then what? Find the distance between them. That is AB we want to find out. If the height of the tower is 50 meter. So height of the tower TO, that is given as 50 meter. So here we want to find out AO and OB. So that we will get AB by adding those two, AO and OB. So let us take the first triangle TOA. So in triangle TOA, which relation we can take? Tan 30, that is equal to opposite side TO by adjacent side AO. Tan 30, that is 1 by root 3, that is equal to TO, that is given as 50. That is the height of the tower by AO. So what is AO? AO is 50 root 3. 50 into root 3, that is 1.732. That is equal to 006.68. Unit is meter. What is angle OTB? This is 90 degree and this is 38 degree. We know sum of the angles of a triangle is 180 degree. That is sum angle property for triangle. So here angle OTB, that is equal to total angle is 180 degree, that minus 38 degree, then that minus 90 degree. That is equal to 180 degree minus 128 degree, that is equal to 52 degree. So this angle is OTB, angle OTB, that is 52 degree. Now we can take tan 52, that is OB by TO. TO we know, tan 52 we can find out the value from the text. and so OB we can find out. So let us write, therefore tan 52 degree, that is equal to OB by TO. Tan 52 we can find it from the table of the text. Tan 52 is 1.2799. So 1.2799, that is equal to OB by TO, that is given as 50 meter. So OB is equal to 50 into 1.2799, that is equal to 59936 will get. Now one more 0 is there in 4 places. So 63.9950, that is equal to 63.995 meter. So we got OB and AO. So what is AB? That is equal to AO plus OB, and that is equal to, in the previous page we got the value of AO as 86.60. Now we got OB as 63.995. So this is equal to 59, then 5.051. That is equal to, correct to 2 decimal places, so 150.60. It is a unit meter. That is the distance between the two persons at A and B. And the fifth question is, a kite is attached to a string. Find the length of the string when the height of the kite is 60 meter and the string makes an angle of 30 degree with the ground. So let us draw the diagram. So this is the kite. This at the point A, and this given as 60 meter. It is above 60 meter. So this is the point B, and that is on the ground, and the angle the string makes with the horizontal, that is given as 30 degree. We want to find out the length of the string. So this is the point C. So this side given, this angle given, this side we want to know. So which relation we can take connecting these opposite side, hypotenuse and on angle? Sine relation we can take. Sine 30 degree, that is opposite side AB by hypotenuse, that is AC. Sine 30, that is 1/2, that is equal to AB, that is 60 meter, divided by AC, that we don't know. So AC is equal to cos multiplying 60 into 2, that is 120 meter. AC, that is the length of the string, that is equal to 120 meter. So okay, thank you very much for watching the video. If you like the video, please subscribe the channel and share this to your friends.